Today we are studying the organization of the periodic table, and there are three main groups that we're going to talk about first. The first are the metals, then we're going to talk about the non-metals, and then semi-metals, and we're going to talk about the properties of these. All right, so the first we have are the metals. Okay, and metals are, throw this in here. All right, so our metals are conductive. Yeah, I'm going to give you a minute to record all these. Okay, our metals are conductive. They conduct electricity. Okay, you guys see this is why we use copper for wires. Okay, because they're metals. In fact, the best conductor we know, or the best two conductors we have, are gold and mercury. Gold, however, we don't like to use that extensively in wires because, well, it's gold and it is more valuable for other purposes. So the next best is silver. Again, it is relatively rare and we value it as a semi-precious metal, and so we don't use it for just wiring. And so the next best after that, the best cost to conductivity, is copper. Okay, and that is what we use in most of our wiring, because it conducts electricity really well. Okay, and it conducts heat. Okay, so we also use copper for our cooking materials. Okay, and other metals have similar properties. It can do this with cast iron also. You know, iron is a metal, so if we use cast iron, it has all these properties. You could conceivably run electricity through a cast iron pan. It's generally not the purpose we would use it for, but you can do that. Okay, so it is conductive. Okay, metals are also malleable and ductile. Okay, malleable comes from the this root right here. Mallet is a hammer. Okay, so if you guys have ever used a mallet before, okay, on your xylophones, or what's the stand-up thing? Is that a euphonium? What's that? Is that the stand-up with the pipes that it's called a euphonium? Slapophone? Yeah. What's that?
You know what that is?
A slapophone?
Yes. You know what that is?
Is that the sound you make when I slap you across the face? No? Okay. Sing! Slap. That's a slapophone. No. You guys, if you've seen the band that they have the stand-up, the pipes are shaped in the same order as a piano, and so it sharps and flats and that sort of thing. And so you hit that. The tool you use to hit those pipes is called a mallet. Okay, and so malleable means it can be hammered into sheets. Okay, and then the same property of metals, or the same molecular property that metals have, also allows it to be ductile, which means it can be drawn into wires. Now, there are other substances that can be malleable and ductile. For example, you can flatten pasta into sheets. That's how you make lasagna. You can extrude pasta into wires, right? But just because something is malleable and ductile does not make it a metal. Okay, pasta does not conduct electricity. Go ahead and give it a shot for us. Try it. No, I'm kidding. Okay, pasta does not conduct electricity, but it is malleable and ductile. Metals need to have all of these properties. Okay, and it has luster, which means it is shiny. Okay, or more specifically, it will reflect light. Reflects light well. Okay, so those are the properties of our metals. Now, our metals, okay, so on the first of your periodic tables, you should be coloring this region, everything that I have here in pink, these are our metals, and you guys should be, okay? We will pause the video here. Okay, or pause the lecture here while you guys color these in pink. Okay, so I do want to identify. You guys see this jagged, this black jagged line right here? Okay, essentially everything to the left of that line is a metal. Okay, everything to the left of this line is a metal. These gray ones down here, we are not entirely sure because we can't keep them around long enough to measure their properties. But everything else is a metal. So we will pause here while you guys color. Okay, so those are metals. Those pink regions are metals. They all have these properties. Okay. On the other side, so that was the left side of the periodic table. On the right side of the periodic table, we have our nonmetals, and our nonmetals have these properties. Okay, and well, basically, they're not metals. That's the property of nonmetals. All of the things that we have up above, where they're shiny, nonmetals are not shiny. Where they're malleable, okay, they're not malleable. They're brittle and powdery. If you have a solid nonmetal, it's flaky or it's very brittle, so you can crush it into powder, and it doesn't, right? You can't draw it into wires. You can't do that sort of thing. Okay, or they're just gases, and so they don't really have a solid form. They're just, right? So they don't have those properties. Okay, and they do not conduct heat or electricity. Okay, and then these elements are the blue ones. So hydrogen, helium, the two on the top, and then everything to the right, except for these 7 elements, which we will get to in a minute.
Thank you.
In fact, I should probably do this in
Just show all of that again.
it's okay. Okay, so these are nonmetals, and your nonmetals should be hydrogen, helium, and everything to the right over here. Okay, except for these 7. Okay, which will bring us to, in fact, we're going to move on to those, so I'll give you guys time to color here in a minute. Okay, those 7 are called semimetals. Okay, and semimetals appropriately have properties that are in between. They're not great conductors. They're kind of malleable. They can be drawn into wires, but they have to be careful. Okay, they're kind of shiny, kind of not. Right? They have properties that are in between metals and nonmetals. Okay, and those in particular are the 7. And the way I like to describe these is that these are they're shaped like the Wonder Woman symbol. right? So you have the W in the middle, but then the Wonder Woman symbol also has the wings on the side. So you see the black jagged line? It's the 5 elements above the black jagged line, and then the 2 underneath in the middle. Can you guys see that distinction? We have the 5 above and the 2 in the middle. And I'm going to recommend to you that you write in the element names. And so I'm going to do that for you guys. These are or the symbols. This is boron, silicon, germanium, arsenic, antimony, which is one of those elements where neither of the letters of the chemical symbol is actually present in the name of the element. It's SB, but it's antimony. Tellurium, okay, and astatine, AT. Okay, you don't have to have them memorized, but it's going to help you find them when you start coloring and which ones we're dealing with. Okay. Okay, so on the pink part of the graph, I want you guys to write. We want. That's not what I want. Save. I want you guys to write metals over here. Not nonmetals. That is semi-metals. Semi-metals in green. And then and nonmetals in blue over there. Okay, or label them how you see fit. Which brings us to the second periodic table that you guys have. Okay, and our families and groups. All right, so our first group, so we have families and groups of the periodic table. That's the next section of our notes here. Doesn't have to be a new page, just next section of the notes. Okay, group 1, we have the alkali metals, which is this first column right here. You probably should not include hydrogen there. Okay, so that first column, we'll draw that in purple. Okay, these are highly reactive metals. That's what's written up there. Highly reactive metals. Okay, and they react well with acids. They will produce hydrogen gas. All right, they will produce hydrogen gas when they are in acid. Okay, and so that first column on your second periodic table, that first column is going to be all purple. Okay. Your second column, those are the alkaline earth metals. Okay, I don't really have a list of properties for them, but know that these are, okay, they are called the alkaline earth metals. I can tell you that alkali metals, their electron configuration finishes with an S1, right? So whatever energy level it is, S1, so hydrogen is 1s1, lithium finishes with a 2s1, Sodium finishes with 3s1. Potassium finishes with 4s1. They all have an s1 in their electron configuration as their last electron that you add. Okay, the alkaline earth metals, they all finish with s2. All right, so that next column right there, those are the alkaline earth metals. Now we're going to go all the way across the page to the second to last column. Okay, and those are, it's group 17. So if you look across the top, of your periodic table, you'll see this box that I have outlined in blue up here. They're labeled from 1 to 18 across the groups. All right, so group 17, okay, is in orange over here. And those are our halogens. Those, okay, are the S2P5 elements. So their highest energy level, right? They have 7 electrons in their highest energy level. All right, and it'll be like 4s2, 4p5 is how they'll finish. Okay, or 3s2, 3p5 is that last column for those electron configurations. All of them have that same electron configuration, that s2p5 is how they finish. Okay, they occur in nature in molecules of 2 atoms. They always appear in pairs. There are a couple other elements that also do this, but all of the halogens do this. They all appear in pairs of 2. So fluorine to F2, Cl2, Br2. Okay, that is their elemental form, is appearing in pairs. Okay, and then the last one over to the right, those are our noble gases. Okay, these finish with S2P6. They finish the P block over here. Okay, and these were some of the last elements that we ever discovered when we were going through all of our elements. Because we just couldn't find them because they don't react with anything. We had to isolate them from air and from other gaseous collections and then run them in a centrifuge and separate them by, find all the things that didn't react, all the gases that didn't react, okay, and then separate them by their atomic mass was the only way that we could find them. Okay, and that's why they're called noble, is because they don't react with anything. Another word for that is called inert. They are inert gases. They just exist naturally the way they are, and they've been that way for millions and millions of years. All right, and that last column is green. Or that's how we're doing it. Okay. And that was group 18. All right, groups 3 through 12. That middle section right here, we're coloring it yellow, and those are our transition metals. Okay, these are all the ones, these are the D block, also known as D block. Okay, these are D block metals. Okay, and what I want you to remember about these is that all of them in the same column have similar properties. So remember when we started this lecture, we talked about copper, silver, and gold all being really good conductors and like the best conductors on the periodic table. Okay. There's a reason that they're in the same, because of those properties, or they happen to be in the same group, okay, and they all have those similar properties because they're all in the same group. Okay, they have extra electrons kind of floating around. Okay, so those are the transition metals. They're the metals in this, and all of the metals in the same column have similar properties. Not all transition metals have the same properties, but all of them in a vertical column, okay, also known as a family. Okay, a vertical column is known as a family. They all have, all the families have the same properties. Okay, in the last two groups, we have the top row. The top row of the bottom block, the F block. All right, so we're going to call these the F block. All right, the top row, they're called the lanthanides because this one right here, this lanthanide that's in the middle, or not this middle, this one kind of separated, that's called lanthanum. And so the series that follows it in the F block are called the lanthanides. Okay, and then the brown one right here is called actinium, and so the ones beneath that are called the actinides. Okay. All of these together are called the inner transition metals. And those are the regions and the names of the families of our periodic table. Okay, feel free to pause the video whenever you want in order to get caught up with the writing or to color in your periodic table. And that's where we're going to stop.